According to Article 334.80 of the National Electrical Code, the ampacity of type NM cable, when used to feed an air conditioning unit, must be based on the 60°C conductor rating. This requirement stems from the fact that air conditioning units are typically considered continuous loads, as defined under Article 440 of the NEC. Continuous loads, as per Article 440.10a, are defined as loads that operate for 3 hours or more. Given the extended operational periods of air conditioning units, they inherently fall under this classification. Article 334.80 mandates that the ampacity of type NM cable used for continuous loads be determined using the 60°C conductor rating. The rationale behind this is rooted in the typical installation environment of type NM cable. It is frequently installed in concealed spaces such as within walls and ceilings, where the capacity for heat dissipation is inherently limited. Using the 60°C ampacity ensures that the cable will not overheat during prolonged operation, thereby mitigating the risk of fire hazards. Therefore, using both Articles 334.80 and 440.10 of the NEC, type NM cable used to feed an air conditioning unit must be sized based on the 60°C conductor rating to comply with electrical safety standards. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC aims to ensure electrical safety and prevent electrical hazards such as fires and electric shocks. It covers a wide range of topics including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for all electrical work to ensure the safety of people and property. The NEC is adopted by many jurisdictions as law, making it a legal requirement to follow its provisions. Electricians, electrical contractors, and inspectors rely on the NEC as a primary reference for safe electrical practices. The NEC is organized into chapters, articles, and sections, making it easy to find specific requirements. It also includes informative annexes that provide additional guidance and explanation. Understanding and applying the NEC correctly requires thorough knowledge and training in electrical principles and practices. The NEC is not a design manual, but it provides the minimum requirements for safe electrical installations. Electrical engineers and designers use the NEC as a basis for designing electrical systems that meet safety and performance requirements. The NEC is continuously evolving to keep pace with new technologies and changing electrical practices. Proposals for changes to the NEC are submitted by industry experts and the public, and are reviewed by committees of experts. The NEC is a consensus-based standard, meaning that it reflects the collective judgment of a wide range of stakeholders. It is an essential tool for ensuring electrical safety and preventing electrical hazards. The NEC is widely used in the United States and is also referenced in other countries. It is a valuable resource for anyone involved in electrical work, from homeowners to professional electricians. The NEC is available in print and electronic formats and can be accessed through the NFPA website. Staying up to date with the latest edition of the NEC is crucial for ensuring compliance and safety. The NEC is a living document that is constantly being refined and improved to reflect the best practices in electrical safety. It is a testament to the commitment of the electrical industry to protecting people and property from electrical hazards. The NEC is an indispensable resource for anyone involved in electrical work, and its proper application is essential for ensuring a safe and reliable electrical system. In more detail about Article 334.80 of the NEC, it specifically addresses the ampacity requirements for non-metallic sheath cable, commonly known as type NM cable. This type of cable is widely used in residential and light commercial wiring for branch circuits and feeders. Article 334.80 states that the ampacity of type NM cable shall be in accordance with the 60°C conductor temperature rating. This means that when determining the allowable current carrying capacity of type NM cable, you must use the ampacity values listed in the 60°C column of the appropriate ampacity tables in the NEC. The ampacity tables provide the allowable ampacities for various conductor sizes and insulation types at different temperature ratings. The 60°C rating is typically the lowest temperature rating listed in the tables, and it is the rating that must be used for Type NM cable unless specifically permitted otherwise. The reason for this requirement is that Type NM cable is typically installed in concealed locations, such as within walls and ceilings, where heat dissipation is limited. The 60°C rating ensures that the cable will not overheat and potentially cause a fire hazard. There are some exceptions to this rule, such as when the Type NM cable is installed in free air or when it is specifically marked with the high temperature rating. However, in most cases, the 60°C rating must be used for Type NM cable. It is important to note that the ampacity of Type NM cable may also be affected by other factors, such as the number of conductors in a raceway or cable, the ambient temperature, and the presence of other heat-generating equipment. These factors must be taken into account when determining the allowable ampacity of Type NM cable. In addition to Article 334.80, other sections of the NEC may also apply to the installation of Type NM cable. These sections may address issues such as cable support, protection from physical damage, and proper termination methods. It is essential to consult the NEC in its entirety to ensure that Type NM cable is installed safely and in compliance with all applicable requirements. Failure to comply with the NEC can result in fines, penalties, and potentially dangerous electrical conditions. Therefore, it is crucial to have a thorough understanding of the NEC and to follow its requirements carefully when working with Type NM cable. In summary, Article 334.80 of the NEC requires that the ampacity of Type NM cable be based on the 60°C conductor temperature rating. This requirement is intended to prevent overheating and ensure the safe operation of electrical circuits. It is essential to consult the NEC and follow its requirements carefully when installing Type NM cable. Air conditioning units are considered continuous loads because they often operate for extended periods, typically 3 hours or more. This prolonged operation can cause conductors to heat up significantly, potentially exceeding their temperature rating and leading to insulation breakdown or even fire. Therefore, the NEC requires that conductors supplying continuous loads be sized larger than those supplying non-continuous loads to account for the increased heat generated by the continuous operation. Article 440 of the NEC provides specific requirements for air conditioning and refrigeration equipment, including the sizing of conductors, overcurrent protection, and disconnecting means. These requirements are designed to ensure the safe and reliable operation of air conditioning systems. One of the key requirements in Article 440 is that the conductors supplying air conditioning equipment must have an ampacity not less than 125% of the motor's full load current rating. This 125% factor is intended to account for the continuous nature of the load and the potential for increased heat generation. In addition to the 125% factor, the conductors must also be sized to comply with the temperature rating requirements of Article 310. Article 310 provides ampacity tables for various conductor sizes and insulation types at different temperature ratings. As mentioned earlier, the 60°C rating is typically used for Type NM cable in concealed locations. However, if the conductors are installed in a location where the ambient temperature is higher than 30°C, or if there are more than 3 current-carrying conductors in a raceway or cable, the ampacity must be derated according to the adjustment factors in Article 310. These adjustment factors reduce the allowable ampacity of the conductors to account for the increased heat generated by the higher ambient temperature or the presence of multiple conductors. It is important to note that the NEC also requires that the overcurrent protection device, such as a circuit breaker or fuse, be sized to protect the conductors from overload. The overcurrent protection device must have a rating not greater than the allowable ampacity of the conductors, taking into account any deterring factors. In addition to the conductor and overcurrent protection requirements, Article 440 also addresses the requirements for disconnecting means. A disconnecting means is a device that can be used to disconnect the air conditioning equipment from the power supply for maintenance or repair purposes. The disconnecting means must be readily accessible and must be rated to handle the full load current of the air conditioning equipment. Article 440 also includes requirements for grounding and bonding of air conditioning equipment. Grounding and bonding are essential for preventing electrical shock hazards and ensuring the safe operation of the equipment. In summary, Article 440 of the NEC provides comprehensive requirements for air conditioning and refrigeration equipment, including the sizing of conductors, overcurrent protection, disconnecting means, and grounding and bonding. These requirements are designed to ensure the safe and reliable operation of air conditioning systems. When working with air conditioning equipment, it is essential to consult the NEC and follow its requirements carefully to prevent electrical hazards and ensure compliance with electrical codes. The correct application of the NEC requirements for air conditioning equipment is crucial for protecting people and property from electrical hazards. Electrical codes evolve to incorporate new technologies and safety standards. It is the responsibility of electrical professionals to keep themselves up to date with these changes. Continuing education courses, industry publications, and participation in professional organizations can help electricians and engineers stay informed about the latest developments in electrical safety and technology. Failure to comply with electrical codes can have serious consequences, including fines, penalties, and potential liability for damages caused by electrical hazards. Moreover, non-compliance can jeopardize the safety of people and property, leading to injuries, fires, and even fatalities. Therefore, it is essential to take electrical codes seriously and to follow them diligently in all electrical work. By adhering to electrical codes and best practices, we can create a safer and more reliable electrical environment for everyone. This includes not only compliance with the NEC but also the adoption of sound engineering principles and the use of high-quality materials and equipment. Electrical safety is a shared responsibility, and it requires the cooperation of all stakeholders, including electricians, engineers, contractors, inspectors, and homeowners. By working together, we can minimize the risk of electrical hazards and ensure the safety of our homes, workplaces, and communities. Air conditioning systems are complex electromechanical devices that require regular maintenance and inspection to ensure their safe and efficient operation. Regular maintenance can help to prevent electrical problems such as loose connections, damaged wiring, and overloaded circuits. It can also help to improve the energy efficiency of the system and extend its lifespan. Homeowners should have their air conditioning systems inspected and maintained by a qualified technician at least once a year. The technician can check the electrical components, clean the coils, and ensure that the system is operating properly. In addition to regular maintenance, homeowners should also be aware of the signs of electrical problems such as flickering lights, burning smells, and unusual noises. If any of these signs are present, the homeowner should immediately turn off the system and call a qualified electrician. Attempting to repair electrical problems without proper training and equipment can be dangerous and can lead to serious injury or even death. Electrical safety is not just about compliance with codes and regulations, it is also about awareness and education. Homeowners, tenants, and employees should be educated about the potential hazards of electricity and how to prevent electrical accidents. This education should include topics such as proper use of extension cords, avoiding overloaded circuits, and recognizing the signs of electrical problems. By raising awareness and promoting electrical safety education, we can empower people to take steps to protect themselves and others from electrical hazards. Electrical safety is a continuous process that requires ongoing effort and attention. It is not something that can be taken for granted or overlooked. By making electrical safety a priority, we can create a safer and more reliable electrical environment for everyone. The 60 degrees Celsius temperature rating for Type NM cable is a critical factor in ensuring electrical safety, especially when dealing with continuous loads such as air conditioning units. Understanding the reasons behind this requirement and adhering to the NEC guidelines are essential for preventing overheating, insulation breakdown, and potential fire hazards. Remember that the NEC is a comprehensive document, and it is important to consult the entire code for specific requirements related to your particular installation. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns about electrical work. By following these guidelines, you can ensure that your electrical systems are safe, reliable, and compliant with all applicable codes and regulations.